on the fans, one thing we might talk about is how do you vary the speed of 1200 horsepower? And that could be your conveyor, that could be air in a wind tunnel on a highway under a river, or whatever. It could be in a subsurface mine, whatever. So what do you want to control to? Do you want to control the pressure? Do you want to control the velocity? Do you want to control the mass airflow? Those kind of things. At the core of what I do in the programming and in the automation, supervising the operator's request, like, okay, you want to turn up the fans. Well, let's see, is this right, and is this right, and is this right? Okay, we'll admit your fan request, and then is this still correct, and is this still right, and is this still right, and is this still satisfactory? And of course, all that happens in like 5 milliseconds over and over and over. The VFD is controlling, monitoring, and protecting the motor. All of those three. That is it. It is your overload protection. It is, on its output side, it is its short circuit protection, and it is also the source of a lot of our key process data is the VFD. So kilowatts, amps, volts, RPM. With RPM, we know blade pitch, we know mass airflow. We have a pitot tube that's referencing that or verifying that. Another component is, major component is the VFD, and then VFDs are merely I/O in a common industrial PLC that anybody could go buy right now. So merely I/O in the PLC, and the PLC is reading inputs, executing logic based off those inputs, and then updating outputs based on those statuses of that logic.